we're here, and it is Tinker Tailor Solder Fry, but we just did that last week, but we're doing it again. Interesting. I wonder what could be up. Folks, it's time for Tinker Tailor Solder Fry here on the mighty Loading Ready Run Video Entertainment Network. My name's Ian Horner, and I will be your navigator as we go through today's activities. Let's trying to fix some things around the Moonbase that we've had in our shelves, in our drawers for a little bit too long. So we're gonna clean up some Moonbase packages, and if we still got a little time, start a new one. But before we get into the activities themselves, we got to remind you that Tinker Tailor Solder Fry, much like everything here on the network, is brought to you by you via your kind donations and support over at patreon.com/loadingreadyrun. I don't have a slogan for them this week. They can just think about what they did recently with regards to their logo. Patreon.com/loadingreadyrun. Thank you so much, everyone, for your support there. And of course, in all the various other ways that you can support us in the network over at youtube.com/loadingreadyrun, over at twitch.tv/loadingreadyrun, and of course, store.loadingreadyrun.com to keep Beej real nice and happy. And busy. We need to give that boy something to do. Speaking of doings, we've also got Paul on the ones and twos in the booth.
Hey, hello.
Or in the crystal gondola, as I'm going to remember to try calling it.
What? I've always been meaning to ask, what are the ones and twos?
I assume that those are the channels that you're turning them. I guess channel 1 and channel 2. But
I feel it's one of those things that I feel like I should know if I'm on them, but I'm concerned.
I think it's something I picked up from a radio DJ years ago and just kept it filed away for when it would happen to me, and it did, and now it's just confusing to everyone. So we'll keep doing it. That's how you make traditions happen.
It's true.
Speaking of traditions, I'm going to end one. We're not going to take this to another Moonbase uninstalled. I believe we started this project way back in Mark IV, and we did wire up a ESP 8266 to it to hopefully do some controls, but we never had the receptacle put up on the wall for it to work. Now we have changed Moonbases and done a number of different changes to the network here, so we're going to attempt to we're going to make this work, but we're going to attempt to reflash this, reset it up, and get this working in such a way that we can have an on-air light over Studio C at the touch of a button. Meanwhile, we've also had these marquee lights for a good amount of time, and we just never turn them on because they require batteries, and you have to do each one individually, and that's time-consuming. Much easier if we could just plug it into the wall somehow and then mains power it. So that's what we are going to do as well. Let's close that down. Come on, go away.
Oh, the ones and twos are the two turntables that a DJ uses.
Is that what it is? That makes
turntable 1, turntable 2.
A lot more sense now. Well, sorry, Paul, we're resending your ones and twos certification, I guess.
Apparently so.
Yeah, we have to send that over to DJ Turnler. And if we get around to it, the final project for today is got to take this. It's an Arduino Pro Micro. That's right, and attach it to this custom circuit board so that it can be used to control things that connect via the Wii Nunchuck port and convert them into PC signals for upcoming rhythm fun.
Okay, I was going to say, that's going to go into the on-air sign?
Yes.
We have to use a Wii Nunchuck to turn it on?
Absolutely not. No. The idea being we're going to actually continue going on. I'm still using a lot of these Sonoff ESP8266s at home for my use, but I've switched over to a different firmware. I use ESP Home on them these days, because it tends to work out a little bit better with integration with Home Assistant. But for what we're doing here, where we kind of just want to have it easily controlled via a push button, I think we're just going to use the Tasmota firmware, as it can be controlled via just simple web GET requests. In order to have the same functionality on ESP Home, you've got to make an HTTP post And that's that's an extra level of work that we don't need here. I want this thing to be just plug and play basically with a Stream Deck. But we'll start, I guess, by cracking it open and getting it powered up so that we can find out what it's currently running and how to make it run better. So it's gonna move my laptop off for a second until we need to use that. And let's break out the mechanical screwdrivers. Friends to all. All right, make our choice. These are Phillips heads. Standard. Good. Good.
So it's basically just an ESP 8622 or whatever.
Yeah, 8266.
8266 being used and then connected to a what do you call it? A switch to turn the power on and off.
It's not even connected to a switch. Let's crack it open here and show people what's going on here. I'm just going to remove it from the wiring too, so we can actually get a good
A
look.
relay. That's what I'm thinking.
Yes, that is. You are correct in that assumption. Let's see here. Push the bottom up. Yeah. So these ones are packaged by the Sonoff Corporation, and they were extremely cheap a long time ago, and I think they still are, if you can even find them online anymore. But there's not a lot to them. You get your leads for the in and out of power. You've got some capacitors. You've got a transformer so that it can self-power itself down to the 3 volts that it runs off of. And where is the actual little module on these guys? I always forget.
So this is marketed as a control a AC or DC powered device with an ESP board.
Exactly. Yeah. AC power goes in, and then AC power comes out, and it's controlled via, as you say, via this big black box, this relay here.
Right.
And yeah, what's different about these ones is they're mounting the chip. This is the ESP8266 itself right there. In fact, if we can maybe go over to the super close shot, we can get a better look in there. Yeah, there it is. So that's our little guy. That's doing all the hard work, and you can see that it's connected to the antenna trace there. Now it gets the Wi-Fi. And the actual power goes through these 2 beefy boys of wiring here.
Wow, those are like beefier than even regular they seem beefier than regular AC cable even. It's interesting.
Well, they are definitely you want them to be that beefy because they are taking that full AC power and going directly from here to there, one lead through the relay to keep it safe. Previous versions of these just had huge traces on the back, going from one side to the other, and they were a little bit less safe. But they're a great way to add smart functionality to something that just needs to be turned on and off. And if you're so inclined, they're also a great place to add a couple of sensors to them, because you still have the access to the GPIO pins that go into the ESP8266 itself.
So you could put like a light sensor or something.
Yeah, I've in fact got one of these running a lamp that I've got at home that is attached to a humidity and temperature sensor that lives in my living room. And so it does double duty, as telling me how hot it is and how humid it is inside the house, and also just being a good little lamp.
So wait, when it's humid, the lamp turns on?
I have not associated those 2 functions yet in the software,
I see. Okay.
But it does do both at the same time for different reasons, let's say.
What's the tower there?
Oh, this thing? I was about to just bring this up. This is literally just a button with a too long, like if you just took the end of the button in a 3D design program and just extended it up.
That's so it can fit through the case.
Exactly. So that connects into right there.
Beauty.
Boop, boop.
That's just the reset button?
Yep, it's just the reset button. It also happens to be a preposterously long tower. And then same thing with your LED here.
Now, does this have a USB port on it, or?
It does not. These particular devices don't have the USB port because as a cost-saving measure. The idea behind them is that you use them with the software they came with from China, which you should absolutely trust and not question at all. Or if you're like me, question it a lot and replace it with something fun and useful and unspy.
So what's the alternative? You can flash it via Wi-Fi? Is that?
Well, you used to be able to do that. That method no longer works with the new versions of the firmwares that are on these things. So the options are to connect directly up to the chip itself on certain pins for the voltage, the ground, the transmission, and the reception of serial commands.
So you have like a separate programming board?
Exactly, because that's what happens when you get these sorts of modules with the USB ports. Is that means they're including the programming hardware on them.
Right.
So it's really it's a cost-saving measure. But they were kind enough to, on these ones, give us the 4 pins, which are those programming pins. And later versions, they just gave you the holes, so you had to wire up your own pins. But this is probably the easiest way to flash one of these things, is just having those pins available and connectable. And that's what we're going to do when we determine what it's running and if we need to do that. If it's already got a decent version of TAS mode on there, we could potentially upgrade it over the air. But if not, we've got flashing options here, which I will need to pull out when we get them because there's a lot of sorting involved. But before we get to that, we need to get power into this. And I think I decided I was going to sacrifice this as our power input device for today. So
it's just a one of those sort of standard dual pin.
Standard dual pin AC to this sort of dual pin, and I'm not sure what the exact certification number or standards number for this plug is, but
I always call it I always call it like it's like 00 or like 0D or like OD like or
right, for
DD
0D, yeah, based on the side of the
based on like
keying.
Yeah, how they're keyed, and
right.
There seems to be very little rhyme or reason as to which ones are keyed and which ones aren't. But I'm assuming it matters for some reason.
I guess it really matters if you're working with a polarized plug, and maybe how the power gets back. Because if it's going into a converter, an AC to DC converter, you can go either way.
Right.
So it'll convert it on the other end. But I guess if you're plugging it directly into the device and the device itself either does the conversion on board or runs directly off the AC, I guess that might be why you'd want a keyed version here, and you'd want the differentiation on the plug side as well to match up.
Yeah, we have a bin full of a variety of different ones here.
Okay, that's that. And let's strip this a bit here. Oh, this is coming apart very nicely.
So you're just wanting to get it as a source of AC power, right?
Exactly. We're not... come on.
I guess just like a random indoor extension cord also would have worked.
Yeah.
But, this is even easier.
I mean, any sort of cord would have worked, but we'd still have needed to strip it.
Right.
Okay, I didn't get enough off the back side, so we'll have to just pull a bit more. There we go. Now we've got enough room to properly strip. So we don't need much, but we do need enough lead to get caught by the screws. But when we do end up mounting this upstairs or above the door, I think what I will do is probably trim down this very same cable to a very short length.
Right.
And then we can just permanently leave it up there. But for the moment, that's all we need.
Yeah, because theoretically it'll be mounted almost directly on top of the plug, right?
Yep. Yeah, it's a recessed plug, which I specifically asked for, and I'm glad I have it, because it does need space for this box and then the plug to come out itself.
One of the nice things about renovating our new Moonbase and stuff is that we were able to basically get them to build it to our specifications in terms of where plugs are, where network drops are, that kind of stuff. Some of that didn't work out the way we wanted necessarily.
Yeah.
You're looking at the plans and you're like, okay, do. And then once you're in the place, you're like, should have gotten a plug right here.
Yep. No, we need more Ethernet plugs there.
But that's how it goes,
Yeah. Okay, so let's start by just plugging her in and seeing where we land in terms of Wi-Fi's. I'm going to use my machine over here. Let's not swap over to the computer view just yet while I examine the Wi-Fi's, just for OPSEC.
Is this one of those like sort of bootstrap connection things where you sort of connect to it as it becomes a hotspot? You connect to it and then get it to connect to the network.
That's exactly it. But where did the Wi-Fi go these days? There we go. Yeah, because we've definitely used this before.
Ooh, I see a light.
Yeah, and it's nicely. It's not doing any flashing, which generally seems good.
I guess I shouldn't be surprised, but it makes sense that it's handy that it's also using some of the AC power that's coming in to actually power the board itself. Like it's routing the power through itself, but then also bleeding off a little bit to power itself.
Exactly.
I guess that would be pretty dumb if it had to actually also have like a big wall wart attached to it.
Hidden network? Sure, let's connect to hidden. Nope. Enter the name of the SSID for this. Okay. Well, I'm going to try one more thing here. Oh, where'd my history go? Because I had in here earlier a potential configuration or a potential IP address.
If it is it on our internal network? I might be able to.
Yeah, if it is on our network, then you should have a look and let me know. But I don't think it connects so quickly. Okay, I'm probably going to need to actually connect this via serial to read what's going on and reflash it. So let's prep for that. Ah, that's where that went. We'll need that for later. So this is good because I've just acquired a new version, or not a new version, but a new device for flashing these sorts of microcontrollers, and I'm excited to see if it works. If not, we've got the old one that we can use to fall back on. But Canada is selling these little adapter boards, you could call them, for breadboards that provide a connection via USB-C, and then pins for your various voltages, 12, 5, and 3.3, and in your serial connections, and then sending ports down the rails of your breadboard.
That's spiffy.
Yeah, it's super handy for this sort of thing and for prototyping out little projects. I've also got the button here because we remembered earlier that sometimes you need to push reset on the buttons before they're able to flash, and sometimes the connectors are very small. Okay, I've disconnected the power from the Tasmota, so we will not see anything from it right now. But I am going to connect things up here to the pins. Let me get my jumper cables. I need to go from male to female. Pokey to holy. Where are my pokey to holies? Are these pokey pokies? Pokey, pokey. Pokey holy. Great.
It's important to get all the technical jargon correct.
And that's probably just enough, too. All right, what do we feel like here? Let's... Thankfully, I have a handy diagram already set up for me. Or, I could just look at the bottom of the board where they list the various pins of ground, transmit, receive, and 3.3 volts. Ground is at the top, so that means, there we go.
Why does it have so many cutouts in the board?
I'm assuming for probably just separation. I'm betting that these areas here that deal with the high voltage. It's absolutely then to separate high voltage from low voltage.
Just to actually have a physical separation.
Yeah, because...
That's cool.
Yeah, I'm happy with that. Anyway, ground. We were going to use gray for ground. That's right. And that goes to you. Number 4. Let's use VCC. Okay, this one's wired. This one's wired different. Me, I'm different. Ground on top, 3.3 at the bottom. Okay, and let's add that to 3.3 on the board here. Let's make sure we are set to 3.3 volts on the system for the programmer. And we'll need 2 more leads for transmit and receive. So the transmit we're going to do from here, and that goes to RX on the board, which is bottom. Now, you were mentioning earlier, Paul, about how nifty it is that this thing provides its own power from the AC. While it does do that, you should never have it plugged into the mains when you are, or into the wall, when you are programming it via a separate programmer like this. You can't just count on the 3.3 voltage coming through, because that will create, or has the potential to create, a common ground with your computer and just fry out anything from your programmer board all the way up to and including your USB subsystem on your computer.
Ah.
So this keeps things nice and clean.
So now it's actually it's changed from being powered over AC to being powered directly from those pins on the board.
Exactly. So
That's cool that it has like alternate power systems.
Yeah. So we're going to plug that right in there, and it's going to install a new driver probably, as Windows likes to do.
On the board or on itself?
On the computer, I think. Or maybe it just already has the driver installed. That would be nice. I like that this thing actually has the your lights for which powers are currently active.
Mm-hmm.
All right, we're going to swap over to Microsoft Edge, because Microsoft Edge has the ability to do programming via the web browser, thanks to Web Serial. You can also do that via Chrome, but I wouldn't. Let's just try hitting connect and see if we need to connect a port. PCI serial port, definitely not. USB serial COM4 seems correct. I think this is something we can actually show off if we'd like to bring up the computer connection. There we go. That's not live.
Might take a second.
Make sure my broadcast is still occurring. Yep, still up for broadcast. Is it just that? Huh.
Are you still going on the network?
Yeah, we appear to be connected via Ethernet, yep. Well, you know what? Let's jump back to... Let's jump back on the Wi-Fi and see if that matters. Boop. Okay. How are we looking now?
Not getting anything. I can see it.
Something exists.
It's advertising itself, but I don't seem to be connecting.
Let me restart it.
NDI is always a little bit like, it's got that auto configuration thing where it's like, it's
Yeah.
great when it works, but when it doesn't work, there's no settings to change. It's just like, nope, it ain't there.
Yes, the Apple computer.
Oh,
issue.
hey, there it is.
There we go. All right.
There we go.
Hey. So, let's refresh there. And yeah, it's as simple as hitting connect from the page now. This is so weird.
You're using the NDI screen sharing thing, right?
Yes.
If you go and open it up, there's a setting to show your mouse.
Okay, that's what's going on here. Come on. Capture settings. Mouse pointer, yes.
Hey,
There you go. Welcome. So, ooh, let's have a look at the logs. Reset device. Download logs. Ooh, there we go. What have we got? Nothing.
Absolutely nothing.
Great. That's perfect. Go away.
So clearly, nothing has ever gone wrong.
Yep. That's what I'm getting from this.
There's no need to log anything because it's all been perfect.
All right, well, let's install Tasmota English. And yeah, go ahead and erase that device. Let's start from scratch.
So Tasmota is just a firmware for the ESP devices,
Correct. That's the name of this particular firmware.
which allows this.
Oh! Try resetting your device or holding the boot button while clicking install. Erase device. Okay, hold the boot button. And then let's depower it. Let's just remove, or let's, just try holding that while we hit install. Try that first. All right, one last time here. Let's unpower. Press and hold the button, repower. Install, erase. Yeah. Serial port is not ready. Serial port's gone. Oh no.
Serial port was never there in the first place. Maybe the serial port was the friends we made along the way.
Try holding down this button here while
I know that noise.
Yeah, so we have reconnected. Install. You know what? Don't try to erase.
Yay! Jason is in the chat. That is his on air light.
Hey!
He sent that to us many moons ago.
Oh, great. That's where that came from. Thank you, Jason. Okay. Let's try again. You know what? I'm wondering if we have the RX and the TX perhaps swapped, so we're just going to turn those around.
You're saying that the pinouts on this one were non-standard?
Yeah, they seem to be non-standard. So let's reset that device. Connecting.
The fact that it gets to here, does that mean that it is successfully connected to it?
It seems like it's definitely connecting. I do remember there's always issues with getting it into reset mode properly.
Is there some arcane, hold down the button for 3 seconds and then turn it upside down? And
Yep. Okay, I'm going to put back these pins in the way I had them before because I don't think that was the issue. Let's double check they're going to the right place though. So blue is our TX, and that's coming from the RX on the board. That's correct. Next one down is orange. That's the RX. That's going to the TX on the board. And then 3.3 is going to 3.3, and ground is going to ground. So that's all correct.
the RX is connected to the TX. TX connected to the RX.
All right, let's
Let's
have a look
next
at
to ground.
programming mode. ESP needs to be in programming or flash mode. Disconnect serial. Bridge GPIO 00 and ground by pressing the onboard button or connect via wire.
Is that what that button does? That big giant button? Or is this a different thing?
I think that's what it's supposed to do, but it doesn't always.
It says disconnect serial programmer and power.
Yeah.
Do it
So
and
let's
then
do
reconnect.
that. So we're going to push the button and reconnect the flasher.
Long button.
After a few seconds, release the button. Let's continue flashing. Connect. Use serial port 4. Connect. If this doesn't work, we'll use one of the actual pieces of software.
The Tasmosizer.
Yeah. The Tasmotizer. Or you know what? It'll just work.
Yay!
And you can see on the board the TX is flashing wildly and the RX is there occasionally also to be friends. I'm really liking this this board thing for the breadboard.
It's interesting. Is the TX light flashing faster than like 30 frames a second?
I think so.
Because it looks pretty steady. Oh, and now it's steady off.
Yep. Wrapping up the install. Because yeah, it must be. It's going to be transmitting characters at. I believe they run at the 11,000 or the 111,000 baud rate. Whatever
Right.
the full information is there. We're complete. We're done. We did it. It gave me the little the emoji for celebration. So let's click next.
I'm sure they're a great company, but I find the name Canaduino somewhat cursed.
Yeah, not a big fan of that either. Okay, once installation is successful, click next. The installer will scan for Wi-Fi networks and select the strongest one. Use the drop-down button to...
Strong Wi-Fi. If it doesn't select our network, we need to talk to some people.
Okay. So wait until the configuration completes and click continue. Well, it didn't do that. Oh, maybe we have to reset it? Let's bring it back up. Boop. Right. Now we disconnect it from this and plug it back into the power. Let it do a full boot.
So now the programming part is done and it can do it all itself?
Ideally. Either that or it didn't finish what it was supposed to do. Let's also disconnect these.
Yeah, didn't you just say something about don't power it up while plugged into your...
That's why we disconnected the USB before we did that. But we may need to reprogram it with an erase. But now that we know the procedure, it shouldn't be difficult.
That's true. On that little help page you were looking at, it did recommend the erase.
Yeah, and I think that might be what we want to do anyway. But I'm going to quickly check the list of Wi-Fi networks to see if we've got any Tasmodas. We do not. So that leads me to believe that yes, we did not fully configure it properly. So unplug from the mains. Hold down the reset button. Reconnect the power. Continue to hold down the reset button and plug it back in.
Whoever came up with the sort of bootstrap Wi-Fi connection two-step or whatever it's quite brilliant as a thing. It's like, how do you configure the Wi-Fi on this device that has no external screen or buttons?
Right.
When Wi-Fi can have quite complex configurations. We make it broadcast a Wi-Fi network. You connect to it.
Yeah. All you got to do is
configure it and then swap the two.
all you got to do is put a web server on it.
And it turns out, a little teeny weeny web server is actually super easy to make to have run.
I know I say it every time we play with these things on Tinker Tailor, but going back in time and telling 14-year-old Ian who'd just seen a presentation on the internet itself in 1994 that yes, you too will be able to have exactly the same sort of server that Tim Berners-Lee had on his next machine, but it'll be on a chip that's smaller than your pinky fingernail.
And, cost $1 or $2.
Yeah.
I
should put a sticker on this actually when we're done that says this is a web server. Do not unplug.
I also I remember when the iPhone first came out, the very first edition of the iPhone, they're showing off all the cool features of it, And like half the whole reason, at least the way that they presented it, as like half the reason it even had a web browser was because usually when you connect to a random public Wi-Fi, it pulls up a web page that you have to like agree to a thing on. And so they were like, because previously it was a real pain in the butt to actually access those on a mobile device, because you couldn't actually, the mobile device could connect to the Wi-Fi no problem, but it couldn't render that web page in order to click yes or agree or whatever.
Right.
And so they're like, yeah, with the iPhone we have Safari and it can do all this stuff. Also, you know, you can browse the web and do all this stuff.
You know,
but mainly you can connect to Wi-Fi networks.
All right. Interesting here. Wi-Fi Manager server is only active for 3 minutes. If you miss this window, you might have to disconnect from your device from power and reconnect.
Mm.
Okay.
I guess that's sort of a security thing, sort of.
So. It makes sense. But yeah, I'm surprised we're not getting any information yet. Yet nothing on that.
Should I switch back to your screen?
You may, but not getting anything on the logs here. That's all right though. Let's just unplug everything from here.
The log doesn't seem to be logging much.
Let's plug it into the power and see if that brings it back. Aha! Green light. I like that. Flashing green light. I like that even more. And let's attempt to... let's not look at the screen for now. Aha! Tasmoda C2E something 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 something. Connect.
Oh, you found the Wi-Fi network? Ah,
I
perfect.
did. I need to quickly unplug from the real network so that I can get the captive connection.
Oh, you can't have the Wi-Fi and the Ethernet working at the same time?
I think that so what it's trying to do, I think it's trying to use a sort of captive connection, so that it'll just automatically open up the web.
Oh, right. And then but Windows is like, well,
I've got this other working connection.
It's like this Wi-Fi connection doesn't have access to the internet, so clearly it was incorrect. I won't use it. Yeah.
There we go. IP config. So we're on. Okay, so it's going to be 192.168.168.4.1, I believe. Hey, here we go. Let's plug back in and see if you can, and then I'm going to restart my NDI and see if this works. Exit, NDI, launch that. And are you running? You are running. Okay.
So I can switch over to it now?
Yeah, you can show things here. Maybe, yeah. Maybe don't. I'm going to have it join our network, and then I'm going to remember what our password is. And by remember, I mean... Thank goodness. Oops. Save. Trying to connect to the network. Oh, wow. And it tells me what the IP address is on the new network.
That's handy.
Redirecting you to the new device's IP address. That's great. Okay, now we can pull back in and have a look on the screen. So here we go. We've got it. And I'm going to, let's test the toggle. And we can find out if it's working by hearing the relay switch. So get ready. Can you hear that?
Oh yeah, I thought that was your mouse clicking, but no, yeah, that's the relay going on.
Yep. Okay, great.
Cool.
Let's see what's here in the configuration. So configure the module. So this is where you can set up what you want your various GPIOs to be and do.
Oh, neat.
You have them as a rotary switch, a relay. Have them set to read pulse width modulation or send pulse width.
Spiffy diffy.
Yeah, all sorts of cool stuff in there.
These are those same 4 pins that you use to program it.
Exactly.
Once it's actually running, it repurposes those.
Plus 14, which you can use as a different pin. And then, of course, there are different models of Sonoff, but this is the most basic one, and so we're using the basic. But some of them do allow for, dual relays and whatnot.
Spiffy diffy.
Yeah.
So is Tasmota to come in and make Sonoff, or are they not actually connected? Are they actually this is like a third-party firmware?
This is, I believe, a third-party firmware for ESP8266 devices and ESP32 devices. They do also, I was reading the chat earlier, make some of their own.
But clearly it knows that this is specifically a Tasmota device, or a Sonoff device.
Yeah, because that's I think that's because what I told it what it was in the initial programming.
Cool.
Yeah. So yeah, we could set up MQTT if we needed to. We're not going to go back into the Wi-Fi for the OPSEC. I don't know what Domotix is, but it is an option. If we wanted to set this up such that we just had it as a simple turn off on during the day for security or for timers, that's built-in.
Nice. So it can just be it can just act as a simple timer thing.
Yeah, I think we have some logging.
So now you were saying, does this have a built-in REST thing where I can where someone could send a GET request to it to?
Yes, it does. And in fact, this is where we're setting this up here. I'm not going to deal with the template, but and we're not going to deal with the web admin password because there is none at the moment. We're going to disable MQTT because we don't need that, but we do have the HTTP.
MQTT is like a low power, mesh network thing, right?
Information repeater, I think, is a good way of putting it.
Home automation stuff uses it.
Right?
Right?
Yeah, it's used for it's used because it's a very quick method of sending data as opposed to TCP/IP.
Right.
And so that's why you need a separate type of server for it. But
that's cool that you can have it. It can pretend to be a bridge and a Wemo. That's actually super cool.
And then that was an other. So yeah, I'll send you the information you need, Paul, for future. But if you go into their documentation under commands here, you've got the various options. You can use MQTT, web requests, or the web UI console, or just straight up serial if you wanted to connect to it that way. But the web request is as simple as HTTP, the IP address, command name, and then we'll actually test that out in just a second here. I'm going to power this down and get it buttoned back up and connected to the light so that we can call this project done.
Now, is there anything, the light already has all the LEDs and stuff in it that it needs?
I believe so. Right? We'll need to open it up to have a look, and let's do that. Let's do that right now. Heck not. Let's find out how it's doing in terms of its internals. I'm going to need a bigger screwdriver. No, just the head. Thank you, Beach, though. Oh, somebody used this incorrectly. Nope, they didn't. They just...
Has somebody been dabbling in your screwdrivers?
I was wondering if that was the case. Uh-oh. Thank you. I love you. That's not helpful. In the best way. Again, Robertson heads for everything. It's like that
Story of Bija's life. I love you, that's not helpful.
Am I running out of power? I think I'm running out of power on my screwdriver.
Oh no.
Yeah, the worst part is I'll need to find a micro... This is one of the last micro USB devices I've got.
Oh no.
It's unfortunate because, well, we all know about we've all had to deal with micro USB. Ah!
Although,
Light bulb's still there.
oh wow. Is that like is that like an incandescent light bulb?
That is, it appears to be an incandescent light bulb. Oh, no, it absolutely is. And it's not, well, if it was labeled with its wattage, that has been painted over.
By the red painting.
To reduce the risk of fire, only use Type A19 75 watt lamp max. For ceiling mounting, or Type A19 100 watt lamp max. Ooh, for wall mounting. Yeah, okay, so we're good with our 100 watts. If we wanted to light this on the ceiling, that would be 75 watt max.
100-watt lamp in that size of an enclosure is gonna get so hot.
Yeah, it wouldn't last very long, I think. But
I mean, might be nice. Yeah, that's literally an easy bake oven. Like,
this is a smaller easy bake oven.
I feel like maybe a red LED a red LED lamp might be a lot more efficient, but
Probably. But that's a bridge we can cross when that light dies. Unless, of course, these sorts of LED or these non-LED lights are going up in price, in which case we'll hold on to it to sell later.
I don't think you can even buy incandescent lights very much anymore.
I'm pretty sure that they have possibly been made illegal at this point. I know there was a deadline, and I can't remember if we've actually, if we've hit it yet or not.
I like your electric screwdriver. It's sort of like an escalator, Like even when it runs out of power, it still stairs.
Yep. I am a big fan of things that fail gracefully.
It's still a screwdriver if you run out of power. You just have to supply it yourself.
Yeah. I'm going to just step off camera for a very short second here to check a length, and then I'm going to clip some wires. Oh, wow. Yeah, that is going to be an interesting fitment, but we'll make it work somehow. I'm going to leave a bit more space or a bit more end on this wire than I thought I was. Just in case it needs to go around. Huh, LED Christmas lights.
Yeah, 100 watt.
100 watt LED, or 100 watt equivalent, or 100, yeah, okay.
Also,
100 watt,
Blue.
100 watt
Hey.
equivalent, right?
blue ones.
100 watt equivalent, it's got to be.
Yeah, it has to be.
14 watt.
14, okay, yeah, I was going to say, no, there are... I mean, even our studio lights, I don't think are 100 watt LEDs.
Yeah, you'd be looking at something pretty powerful if it was 100 watts of LED power.
Purple.
Ooh, purple. For all the gamers.
I wonder, like, in terms of the space, I know there's sort of right angle plugs. Would that be, is that what you need?
So the outlet itself is recessed. but is still pretty large. We're going to have to look at ways to mount this, I think, and then maybe change the outlet or change where we put the ESP itself, because I don't think I can very easily. I mean, there's some space behind it, but not much space behind it. So we'll also need to look at how it's actually connected to the wall using this thing and whatnot. There are decisions that need to be made, but.
Let's just see if it turns on, I guess.
Exactly. If we can make it work the way it's supposed to, then we can worry about mounting it, and then we'll never need to take it down again.
I mean, one of the nice things about an incandescent light is, it's not picky about the power, right? You just run your power into it, and it just gets brighter or less bright depending on how much power is going through it.
And if it's something that's meant to be in an incandescent lamp enclosure, then it can also handle that.
Like, it's literally. I mean, it is literally a resistor.
Yep.
It's just sitting there.
Meant to work off of AC. Nobody has to be sad.
You don't need the ballast or all that stuff.
Mm-hmm. Yeah, that's the big issue with LEDs is their control circuitry and their need to their requirements to have the LED itself to have DC power. Okay, the input is. The one thing they don't do is label input and output on the device itself, only on the shell. So
that seems important.
Yeah, you'd think so, right? You'd think you'd want that to be readily available information. Okay, let's really just.
To get that, you need the Pro model.
Right, this is the other thing I need to remember. So, notice anything about this shell? Yes, I'll give it away already. I need to put the wires through the edge of the shell first before I connect them to the device. Otherwise, you can't get that top shell on. So, bottom on, wired through the top. And in you go. Back in your holes. Come on. You can do it. I believe in you, tiny little copper strands. Get in there. Twist that down nice and tight, because we don't want it to come out accidentally, and we don't want to strip the screws either. Next up, the other side. So let's also... This one we can probably do it with everything connected up. So let's just
That's what the holes in the top are for?
Exactly. You've got a little bit of space that you can kind of get a screwdriver through. Kind of. Okay. So that's one in there, and then we'll just tighten it up and then get the other one. Good. Give it a little bit of a tug just to make sure it's connected and tight, but not so much that you accidentally pull it out and ruin everything.
Does the polarity of this... I mean, technically, this does matter in terms of which part of the socket is energized, right?
Exactly.
I remember changing a bulb for my grandma one time, and the socket had been wired reverse. And saying some things that you probably should say in front of your grandma when I touched, I unscrewed the bulb and got a real nasty shock.
Oh.
And sort of my hand just like I was reaching above my head, and my hand just like contracted all the way down. Which was, luckily I wasn't in a position where I was like holding something or whatever.
Yeah,
but-
contracting down, always better than gripping to death. All right, we're also going to cover up those holes with a little bit more, friction. These little end pieces have little teeth on them, so that should keep things nice and clean. Hey, there we go. We've got this one connected such that it doesn't have bare wires extending past the edge,
Yay.
which is something, a problem I've had on earlier ones of these that I've made.
You just strip the wire a little too much.
Exactly. And they were, it was a cable that had a fabric coating to it as well, because I want it to be fancy. It's the ones I currently use as the extension cord for my for my wheel setup, which caused an interesting bug to occur when I was dealing with it during the Le Mans. So by default, they're set up to just work as a standard pass-through light switch. You can either set it so that it's always on or always off, depending on how you want it to work. But if you don't have it set for anything, after 24 hours, it will turn itself off or on, the default configuration of this previous version. So halfway through the Le Mans drive, my wheel and everything goes dead, and I can't understand what's going on until I realize, I need to push the little black button to turn everything back on again.
Wait. After 24 hours, it just turns there's a chance that it can be set so that after 24 hours of being off, it just turns itself back on.
Yep.
That doesn't seem safe.
Bad timers. All right. Well, it is plugged in, and it is getting power. And if you click the button, you can get the on-air off working.
Wait, isn't the button the reset button though?
When
or it has been repurposed?
Yeah, when it's been repurposed, that just becomes the swap modes on the what do you call it, relay button. But let's see if we, using the web interface, can get it to turn on. Come on, toggle. Ha ha! Okay.
Nice.
Okay. Last thing I want to try here. So let's get that in there. And let's find out what the actual HTTP command is. Commando. All right. Notepad. Give me Notepad. And we can swap back to the screen now if we want to see this. So let's just take this command, go over to Notepad, and grab the IP address of our device. And there we go. So let's throw that into the IP section. And then get rid of that. All copy. Let's head on, and you know what? Let's just put that in the web address there and see what happens. And
Wait.
once more.
Wait, let me try.
Have you got the connection, or do you want me to send it to you?
Oh, wait.
That was you, right?
Yeah, that was me.
Yeah. Okay, it's working.
And it even responds with some JSON saying power on,
Hey, that's actually super handy.
power off.
So yeah, my thought is that at the very least we can we can attach this now to a button on the Stream Deck that can also glow on or off depending on what mode it's in, and very easily let people know that, hey, quiet down, close the door.
Yeah, Stream Deck has a built-in has easy functions for sending GET requests. So that's great.
But yeah, for something that only needs to be turned on and off, one of the easiest ways of making that happen, in my mind. And yeah, just a handy option. So that's project 1, and we are just over an hour here. So that means that it's probably time that we should take a wee little break here, get up, stretch our legs, swap our fluids, and then we'll come back and move on to project number 2 of tonight's lineup. Stay safe. Don't go all the way away. We're just going to run a few ads. Be right back. Welcome back to Tinker Tailor Solder Fry, where we continue to be on the air and have completed one of our several projects we wanted to get done tonight. We've, as we said, finished the on-air light. It now responds to commands via the web and will prove good to us, I'm sure, in the future. Just cleaning up my various pieces of equipment for flashing things, because we're done with that. Really happy with that today. And we'll have to put this back in the correct office. But next up, we are going to attempt to take these lights and make them powered by a wall wart, because that's going to look much better and be much easier to use than the other options. I'm going to...
Now, I guess one could also, remotely control those, but not necessary in this particular circumstance.
Yeah, we can add that functionality later on down the line in a very easy manner. But got to pull out some stuff that I salvaged from the trash years ago when we were doing a lot of stuff with rope lights. They came with a lot of these little things, which are a barrel plug with bare wire ends on it, and a barrel plug receiver with screw-down terminals. And these are super handy for making things that are not currently mains powered, because you can add power very easily using a barrel jack. Now, I'm not going to use this end here right now because we don't have anything to hook it up with. But we do, however, have this little friend here. I have no idea when this entered my life, but it was sometime in the deep past, because I think I've had this since I was a child. And what it is it's just a multi-voltage power adapter that you can select between 3 and 12 volts and between 100 and 300 milliamps of power. And that should be enough for what we're doing here today. The other nice thing about it is that on the other side, depending on what you're attempting to power, you have many options, including several different barrel jacks, mini jacks, which are something that I've never actually seen in the wild powering something, and then a 9-volt battery adapter, which can be very handy if you're attempting to make something that usually takes 9 volts work off the mains.
Huh, that is a super handy thing.
Yeah, so we're only going to use it as a test piece for tonight. It's really the poorest man's bench power supply.
I love the idea of little tiny child Ian saving up his allowance to buy a multi-connector power supply.
I mean, I think it was actually my father buying it because he was getting sick of buying 9-volt batteries for some of tiny Ian's toys.
Oh, there you go.
Yeah. But let's just get out the multimeter, do ourselves a quick reading, and make sure that it's putting out what we expect it to. Boo, boo, boo. Let's take it down to 20 volts and stick some probes on there.
So now you're connecting it. This is connected directly to the AC.
Yes, and I'm getting
Nada.
nothing, no volts whatsoever, which is troubling. Maybe it's not sticky enough. Let's see here. Okay. Is this thing actually working? Let's plug directly into the cable itself. Okay, there we go. And it's, you know what, that's a lot closer to 5 volts than what it says on the label. Let's just click that up to 5 and see what happens. 4.5 goes to 6. 6 volts is 8.43. So, okay.
I'm starting to think this may not be an extremely precision machine that we're dealing with here.
Yeah, I think you may be right. Let's just plug that back in and make sure that...
But the barrel connector is not.
yeah, is it a continuity issue? Is that where the problem is? Let's see here. So let's yank that out there and see if we can get either of these two. Okay, that's connecting. Huh. Let's try the other side here. See if that's a better fit. Just one side. Come on. Are you kidding me? I hope we're not in a situation where this this piece has actually just failed itself. Okay, let's try, just for fun, let's try the 9-volt side. Okay, and then that means the other side should be... okay, the 9-volt works. Why does this not work?
Is that? I mean, is it the little that little adapter thingy that's not working?
I'm beginning to wonder that. No, okay, that's negative. Let's see about the interior pockets. Okay, is this the broken piece then? Because if it is, okay, that's that. And then the positive. Okay, that's fine. Is it just that this is too roughshod for it? Let's see here. Yep, I guess it just doesn't make a connection to this particular type of barrel adapter. Weird.
Despite the two different options, neither of them work.
Yeah, I think they're both a little bit too. Let's see if I can bend it and make that work. This is, what are we doing, Ian? All right. Huh. It's the outside edge that seems to be the problem. And then on the other side, it's too thin. Okay, negative and positive. Yep, okay, so this barrel connector is not properly rated for this thing. How do we want to work with this now? Can I just bus around and find out? Jam those in. This is the dumbest idea. Okay, and then let's take that down to 20. Find out if we get any voltage. 14 volts.
Like you're trying to, we want like 3.3
Yeah, that's what we want.
although if we want to run all three, do we need 9? Is that how that works or not?
So we want to keep the voltage the same and just increase the amperage because we're adding more
Right.
more
Okay,
lights. I think the answer, to be honest, is we're not using these lights on battery at all. So I think the answer is just let's connect them all together, and then we can worry about power, how we get the power after the fact. Maybe we can find.
So the idea is to connect them in series.
That's what I'm thinking is the best option here. And we've got these nice little connectors here too, which could be handy to repurpose maybe.
Although theoretically we should have 3. So one of them didn't even have the plug. So
Yeah.
I wonder where that went.
Oh, you know what? I bet these might actually be the same style of battery connector as what was used on the what do you call it? The T-Rex suit, the inflatable one.
Oh,
So we might have repurposed one of those for that.
do those really only need 2 batteries? I thought for sure a vacuum or whatever, a pump like that would need more than 2 batteries.
It might be that it is used a 9 volt, but these do seem familiar from somewhere. But regardless, we've got pin connections, so technically we could crimp this together if we wanted to. Why don't we do that?
So this would be just connecting the output of one to the input of the other?
Yep, and then back the other direction. Yeah. If Beej is still in the building, maybe we should have him look in the drawer of wall warts for a, as we were talking before the stream, for a 3.3 volt option there. All right.
Yeah, I know we've got a variety, but I think a lot of them are probably like 5, 9, and 12. Not 3.3 is like not that common for the regular wall wart.
Not for those, no. But I feel like these could probably take 5 volts if they're LEDs. They don't give you the they don't give you the information on the actual piece as to what they what sort of electronic requirements they have. But yeah, I'm just thinking now the best way to wire these together is probably use some ribbon cable and go with the black and white end. Yes, let's do that. Had to use some of this already for a replica of something that I was building up. Just have to remember what point in the wire I've cut down to, because you never want to be without all of your ribbons in a ribbon cable. So they don't go too far away from each other. They're basically about that distance, right? So we can be pretty cavalier about how we wire this. But I think I'm going to be nice and do up some DuPont connectors for this. Let's be fancy. It's been a while since I've crimped on air. Actually, let's just make sure that the DuPonts will go into the hole and hold nicely. And the answer is, oh yeah, that's good. That's not going to accidentally get unplugged without someone noticing it. And blissfully, I'll be using my pointy connectors rather than my holy connectors. When you say it like that, it sounds less correct. As a tech priest.
My fantasy is to replace the majority, if not all, of the stupid AC wall warts we have around the office for so many different devices. And the multiple drawers full of rat's nests of AC wall warts. to replace them all with like nice USB connectors, and then any generic little USB plugs.
I would honestly love to go even the step further and go to the all USB-C lifestyle.
Mm.
And just make USB on the wall.
USB actually on the wall is cool. Yeah.
And then you can USB-C on the wall and then plug it to whatever you need on the other side.
I mean, I guess USB, although you have, if you need to extend, like you don't have that much distance on USB-C.
No, unfortunately not. But I mean, if it's just carrying power, you're probably going to be fine. As long as it doesn't require, power delivery. And when I say power delivery, I mean in the capital P, capital D, name of the protocol, power delivery.
And of course, because it's USB-C, there's no way to know what what one particular cable will be able to do. Because that's fun.
But what you do know is that you'll be able to plug it in anyway. Not that it will work if you plug it in anyway, but you'll at least be able to plug it in anyway.
Right. I forgot. There are actually some USB setups that are not.
Yep.
Which is literally the one. That's like the whole thing.
The number one feature that we wanted out of USB-C was the ability to just plug it in regardless of orientation, and they took that away from us too.
Yeah. USB-C is a standard, but the part that's standard is not the part you think is standard.
Yep.
The connector is standard. It's like that you solved a problem that we didn't really have. Like the fact that the ports were all different on the back of computers, like annoyed people, but
It's not the worst part.
And it's like that wasn't the replacing them all with just the same port doesn't fix the problem. If all the ports still do different things, they just have the same look to them.
Oh yeah, you think that's a USB-C port there, but that's actually a display port. Oh, unless you got a different cable, in which case it's full Thunderbolt.
And what's the difference? How long do you have?
Yeah, yeah, that's.
They're different in a vast array of usually not important, but sometimes very important ways.
How much time you got? Okay, so the big problem with this particular set of crimpers that I own is that they crimp the back end just a little bit badly. I can probably adjust them a bit, but it makes it difficult to get them into the connector, the little plastic piece itself.
Crimp the back end. Yeah.
Okay, that went in actually quite pleasantly.
Yeah, the next version of USB is just barrel jacks again.
Okay, so that connects well. So, assuming that we go black to black and white to white, right? Yes, that's how it. We can turn it around later, but I think that's the correct method. And then the last one's going to have to be double crimped too. Yes. So I guess we only need about that much distance here, because these are going to be pretty close together. Let's say about there.
So the idea is like one is power and one is ground, right?
Yeah. And this one is going to have to be double crimped as well, because it's, or not double crimped, but double ended. So let's give them a bit more than we think, because that's, we can.
So now theoretically these could be wired in series or in parallel, right?
Correct, but I believe they're already run in series. So
Right. Looks like the LEDs on the on the actual letters are wired in series,
Yeah.
which makes sense.
So I think we'd want to continue with that rather than trying to wire 3 series based.
So that'll just basically make it so that all of the LEDs are one big series.
Yes. Yeah. Rather than having 3 different series based letters in parallel on their own.
Yeah, my understanding of electronics is very poor in this regard.
Yeah. I you know what, I won't say that I know exactly what I'm doing all the time, but this seems to make sense. At least this time. I should take some more courses. I should read the books that I'm laying out more in my jobby job. Hopefully, I get to lay out an electronics or an electrician manual soon. Okay. So this is going to be the hard part, is getting these crimped together, if at all possible. Which may not be possible, but we're going to try. Okay, twist the ends together to give it a little bit of structure. And then let's see if we can get that into the hole. It's pretty small, so that might work. Nope. Need to straighten. Try again. Twisty. Let's twist all the way down. See if that makes a difference. These wires might just be too big to do this with. In which case we'll just need to strip them more. I've done that before. I think that's what we're gonna have to do. Yeah, we're gonna have to just strip these more and then hope against hope. Back there. And we'll have to do that with the black too. We could probably add some insulation to it as well, some shrink wrap, but might just be more trouble than it's worth. Okay, and let's do these two. The other option is I could just use some Wago nuts to do this, but I'm going to try this first, and then we'll break out the Wagos.
Wacky, wacky Wagos.
Wacky waving inflatable Wago man. Okay. Enter the hole physically. And get crimped on. Okay. That mostly works. Let's close that up a bit. For series add, so 3.3, you get 3.3, 3.399. Okay, yeah. That makes sense.
I mean, I could probably dig up a 12-volt power adapter.
Yeah, we could give that a try. It'd probably be fine, to be honest. But I feel like I've got that connection made, which is the important thing.
These were previously battery powered with 2 AA batteries.
Mm-hmm.
And if the batteries are like beside each other but inverted in terms of orientation, then that means they would be in series, right?
Oh, yeah. These are absolutely in series, yeah.
Yeah, so 3 volts.
I mean, we can multimeter it too if people want to check directly, but I believe we are correct. Okay, that's 2 of those, and those came together pretty okay, I want to say. So let's jam those into our connectors. Again, we've got black on the keyed connector, so let's continue that in terms of consistency. Need to trim it down a bit still. Not trim it down, excuse me, close it up, squish it a bit.
Trim it down. Close it up. Close it down. Trim it up. Squish it in. Rawhide.
Bop it.
Bop it. Spin it. Pull it.
And then we'll just use our side cutters as a makeshift plier to pull that through, and it looks good. Yeah, these terrible side cutters see a lot of multi-duty.
Once you have the God hands, you're like, why this other side cutter might as well just be.
What are these even for?
It might as well be a pair of tweezers.
Okay, let's check while we're still working on this in the middle, continuity. So we're not surprised later. Black to black, black to black. Good, white to white, white to white, and no crossover. Mother. Hey, remember when I said let's keep things consistently keyed? I lied. So now we got to reverse the polarity on this one.
Oh no! If Star Trek has taught me anything, that reversing the polarity is a serious matter.
Have you tried reversing the polarity yet?
So, I pulled a random adapter out of the drawer here.
Mm-hmm.
9 volt, 200 milliamps.
9 volt, 200 milliamps.
The one thing, the thing that I cannot get my mind around with these like DC wall warts is the power that they deliver seems to have no connection to the size. I've seen ones that take up like 3 outlets that deliver, 5 watts or something, 5 volts at 500 milliamps, and I've seen teeny weeny ones
that'll put out 12 volts at
that put
various
out
amps.
massive amounts of things.
Oh, come on. Why do I fail at the fiddliest work? Okay, we'll try the other one then. No, pull out, ow. Don't crimp yourself, Ian. Crimp others before crimping yourself. Yeah, just trying to release the plastic keys on this.
The thing that once I realized that, like, I don't know, the way it's weird the way batteries work, like the whole, obviously there's the thing with alkaline batteries that they are nominally 1.5 to 1.2,
Mm-hmm.
and then as they discharge, they start delivering less and less and less. Which is fine. I mean, that's sort of what they're expected to do. And in fact, that drop in voltage is used to see how dead the battery is.
Yep.
Whereas rechargeable batteries, like nickel metal hydride batteries, like we use in our wireless microphones, for whatever reasons that I am not fully aware, I don't understand why this was made as a decision or whatever, or whether it's just like a fundamental fact of the whole system. But rechargeable batteries run at less. Like alkaline batteries are 1.5, rechargeable batteries are like 1.2 or whatever. But they stay consistent.
Yeah.
Right to the end, which means that that a lot of circuits that are expecting alkaline batteries can't tell when they're low.
Exactly. As Rockbusher points out in the chat there, it is the chemistry of the battery, which is why lithium batteries, not necessarily lithium ion, but lithium...
are always 3.3.
Well, the lithium dry cells, the way that they also work is that full voltage until they die, and then it's an immediate drop-off.
Right, I get that part. What I don't get is, couldn't they have tuned the thing, like put a little bit more of the catalyst in or whatever, like tuned the battery such that the thing it's trying to replace, it would deliver the same power as the thing it's trying to replace.
Mm-hmm.
Like the fact that rechargeable batteries deliver different voltage than alkaline batteries messes things up in some situations. Like our mics do, in my experience, I've seen that our mics do sometimes work better with non-rechargeable batteries in them.
No, absolutely.
I don't know if that's because they get that little extra oomph because they're actually at higher power when they're fully charged or what, but and it's frustrating.
Very much so. And I think, yeah, well, let's blame generations of electronics working on a singular battery standard that has never changed.
It's the closest they could get, I guess, because they have to keep it the same size as AA's, and then I don't know.
Yeah. Like, could you imagine if we actually had, if battery technology had changed as fast as just every other piece of technology over the past 40 years? Like we'd be on like our third generation of AA replacement style batteries right now.
I mean, yeah, in the non-AA form factor, battery density in sort of the kind of laptop battery style has, increased quite a lot.
Mm-hmm.
But unfortunately, there's the fundamental problem with batteries in terms of power density is power density.
Yeah.
Like if you developed a battery that has 5 times as much power density as our current batteries, that's great. But if it explodes, it's 5 times a bigger problem than the current one. Fundamentally, you're putting a whole bunch of energy into a very small piece, and so it's like at a certain point you don't want it to be more energy. Like at a certain point you've just put a bomb inside your phone.
You're basically saying to people, look, there's a lot of energy in this, and it's going to come out one way or the other. Now it's up to you to decide how it happens. It can happen all at once, or it can happen slowly. You don't want it all at once. Ah! Uh-oh. Not uh-oh. Just, there's now a pin somewhere on the ground here that I'm going to let the vacuum find later this week.
Okay.
I would. I hope I don't need to remind anyone in the building, but or in the employee of Bionic Trousers Media, but you probably don't want to go trouncing through Studio C barefoot anyway. I will look for it a little bit later. But Vacuum Chan's a lot better at this job than I am, especially with my eyes. When do we convince James to pick up one of those new Dysons with the laser beam on the front? That might just be useful just for finding the things. Uh-oh.
I do like that. That's like one of the the big continual sorts of innovation in vacuum cleaners is not, more powerful suction. It's different new ways to illustrate to you how dirty things are and how much you need a vacuum
Yep.
cleaner.
You could be using this more. I mean, I guess the other option is to, have the machine send you notifications nagging you to use it more, like your mother. How come you're not vacuuming more? Your place is looking pretty dusty.
I remember a while ago seeing an ad for a vacuum that had like a little like meter on it. I have no idea how it would test this, but it had a little thing that was like, dirty, medium dirty, very dirty, and clean. Like it had like, and so you could, it was probably just like measuring the volume of particles it was picking up or something. I don't know what it was working on, how it was evaluating how dirty a particular section of floor was, but it would sort of tell you when the section of floor you're on is clean.
Like, yep, you've gone back and forth over this particular part enough.
Which I feel like if you're vacuuming and you can't tell that it's making a difference, then maybe either your vacuum isn't doing a very good job or it was pretty fine anyway. But
I would hazard a third option as well, is that you own cork floors, which are very difficult to see dirt on.
that's true.
They're great for making them look. I wasn't going to say clean. I guess just not dirty. You can't tell. All right, there we go. So yeah, completely messed up that job there, and we need to recrimp. And this wire tape has some terrible amounts of plastic on it that's keeping the wires from getting into the holes nicely. But you know what? This is the job. This is what I signed up for. There we go. Yeah, if you don't own a set of wire strippers, that's an easy upgrade that I would highly recommend. I'm actually going to take a second just to see if I can melt down that plastic just a bit to make it easier. Shh, no one tell Heather. This is Ian's secret fire podcast. Ooh, that makes it look ugly. And doesn't help at all. Well, now we know, though. Now we know.
You'll never know whether fire will help unless you try it.
It's very true. I mean, you could, look to the greater knowledge of humanity to see if anyone's tested this, but honestly, with a project like this, it's probably more difficult than it's worth to look up the source of this this particular wires, coatings, and whatnot. All I know is that in the state of California, it absolutely contains something that gives you cancer, because everything gives you cancer in the state of California.
Wow. What happened to California?
Well, they passed a law telling people that they need, if there's something that might make you get cancer, you have to put a label on it. So there's a lot of labels on things now.
Oh, there isn't like some sort of field in California that when you move things through it makes them more likely to cause cancer.
Is that what Californium does?
I remember actually seeing a thing talking about that, because every once in a while some big thing will come out about whatever the FDA or some scientific body says like this. It's like, oh, by the way, this thing that everyone's eating or drinking you may not, I can't believe people are eating this. It's on the list of possible cancer-causing things. And it's like, literally everything is on that list unless they have definitive proof that it doesn't cause cancer. Like, there's different levels of possibly cancer-causing stuff.
Yeah, this is...
And it's like, the cancer, just there's lots of things theoretically have the potential to cause cancer if you ingest enough of them.
This is the double-edged sword of doctors also being public relations people and
Right.
education, is that by their very nature, their oath to first do no harm also applies to advice that they give. So unless they can be absolutely certain that no harm will occur, they cannot endorse otherwise. And so they absolutely always have to go with the safe option. So if something might cause cancer, well, it might cause cancer. We don't know, but you absolutely have to know. It might give you cancer.
And cancer is a very, like, cancer isn't like a specific thing.
Oh yeah, no.
It is just what we call when cells stop doing what they're supposed to be doing and replicating themselves.
Yeah, there's a very good book about the history of research and understanding of cancer, all the way back to Roman times.
Really?
Yeah.
Wow. I guess they can sort of decode and realize what people were probably talking about was.
Mm-hmm. I mean, and there were autopsies. Well, not technically autopsies at that time. They were just people cutting apart dead bodies. But
what is an autopsy if not people cutting apart dead
a
bodies?
very controlled method of taking apart dead bodies. Why did I call it taking apart? Like, that's the... All right.
That's the, oh, sure, but when I do it.
Okay. I think I've done it. Just going to add these wires to this barrel connector here, and then we'll see if I indeed have done it. Let's twist those up and fold them over at the ends because they're too long to fit in the barrel connector's screw-down terminals. But that's okay. The extra wiring will be handy for holding. Make sure I've got an appropriate bit to turn those screws. Get in. You're too small. For the amount of torque I want, you are too small. All right, and let's... In you go. Into the hole with you. Next question. Do we have that barrel connector handy?
The one I was just mentioning, that's 9 volt?
Yeah, the one that's 9 volts.
So it's 9 volt, 200 milliamps. Not 200 amps. 200 milliamps, which seems very low, but I don't know.
I mean, if we're going to test something out with an unknown voltage, the lower the milliamps probably means less potential damage. That one there. Okay.
Yeah, the question is the barrel right?
Yes, that's going to be the big question. Ooh, that one looks like it might work out. Actually, and in that case, before I plug this thing into the lights, I'm just going to see what it outputs for us. Okay, so that's keyed to, well, yeah, we'll do that later. Plug in your on. And survey about our... Oh, hey, great. The light actually makes sense now. Go to 20. Turn that light back on. Okay. So, wow, that puts out a very
Wow.
consistent 9 volts.
Suspiciously consistent.
Let's see what happens when we touch some lights. Just gonna touch them and okay, let's make sure we're actually not getting that voltage on that on the pins too. Okay, so the pins are putting out 9 volts.
So you're just plugging into one right now?
Yeah. Let's put them in series and see what happens. Plug them all in. You know what? That also occurred to me that
Except if we're doing them in series, don't we? The problem is that we don't want 9 volts going into one, right? The whole point is that when they're in series, we have to put higher voltage in.
Yeah, that's correct. I just wanted to make sure that I've got the polarity right too. Is the other question,
Right,
because they're LEDs.
And
So
because barrel connectors are stupid that way. That sometimes the internal and external pins can be
Like I could
wired
s-
separately.
I can easily swap it around, but okay. So that means that the key is on the left. So it's turned on. Okay, so that's giving me the minus voltage if I do that. So a red key and black to not. Okay, red to key, black to not gives me negative voltage. Okay, so let's unplug that from there. And then go from red to key. And then gives me negative voltage. Okay, good. It's wired up the way we want it to be. So let's unplug that and then try them in series. See what happens. Key. Let's also check continuity once we get this all connected too. Just one more time for fun's sake. Okay, good. Turn that off. And multimeter in continuity mode. Let's go. So, negative to good, good, not good. So we need to possibly need to recrimp that one. Is it the wire? I can tell by just piercing the wire. Hopefully not my finger. I think it got pulled out, dang it, then during the crimping procedure somewhere. Oh, no, that's good. Okay, that's not good. How's black, though? Is black connected all the way up? Yep. Okay, that one's not good, but this one is good to the white. Okay. Let's see how she goes when we add some power to the mix. Well, that looks good to me for those. I guess now we just need to recrimp a couple of wires.
So the fact that only 2 of them are on there means that theoretically that was driving those LEDs too hard. Like it was putting too much voltage into them, right?
Mm-hmm. Well, maybe not too much, but more than it's getting normally. That's for sure. Okay, so we need to disconnect this white one here. Oh, I see what's happened. Yup. That white wire just disconnected right in the crimp. So that's going to just be another crimp on that one right there. But that's a pretty easy fix. Ow. Okay, so we need to lift it again, which means I need another one of... I still haven't found a good, reliable tool for lifting these locking keys on these DuPont connectors. But if anyone's got any good suggestions, type them now in the chat. Oh yeah, that was a pretty ugly crimp to begin with, so let's just... Let's start by cleaning up some edges there.
Wow. Somebody, folks in the chat were talking about you can get lithium-ion AA's that are 1.5 nominal voltage. Which is kind of interesting.
Bet those are expensive and not easy to charge.
I mean, yeah, this was, I don't know, Texan Reverend linked to one that I think it was like $50 for 8.
Whew.
Which, I mean, it's not actually that out of the way for high capacity nickel metal hydrides plus a charger.
If you were buying AA's on the same frequency we would be for our microphones, yeah, that would amortize pretty quickly.
But the other weird thing though is because they have like their I don't know what the nominal voltage of the lithium ion is naturally. I guess maybe 3.3 or something. I don't know. Whatever. It's not 1.5. So they've got electronics in there anyway. And so like here's people selling for $40, 10 batteries that have built into each battery individually has a USB-C port in the battery. So you can charge it.
This is an evolution of a previous AA rechargeable AA I've seen.
Which is like, I understand what you're trying to do, but I think that is not a scalable idea.
Yeah. The previous version I've seen was the USB, or it was a battery with a USB A port hidden underneath the top cap.
Right. Yeah. Yeah. And then you can just you can plug it in, assuming your ports are not obstructed by other things, which
Yeah.
they often are. Although you do have to be kind of careful with batteries, especially online, you know.
Oh yeah.
I love, you sometimes see like, you know, people do teardowns or whatever of, you know, batteries off AliExpress or, you know, some,
Your various drop shipping companies.
yeah, various drop shipping companies. And, you know, they'll be like the battery and it looks totally fine. But they, and you know, especially like a lithium ion battery with connectors in it and stuff, it'll report, you know, all the information on the chips and stuff. Then they open it up and it's like literally, you know, like an alkaline AA that's been like hot glued to a thing and wired into us.
So I think I told the story in chat here a while back that I recently tried buying a Apple wireless battery charger, or wireless backup battery for the iPhone, used on eBay.
Like wireless backup battery?
Yeah, they MagSafe themselves to the back of your phone.
Oh, I see. Right.
And the smart and the Apple, the genuine Apple ones, do temperature monitoring and have a few other smarts in it to
and
regulate.
so they charge it via just the standard induction thing.
Exactly, via the induction, but with some smarts to them, so they're not overheating the batteries, so that they're minimizing the amount of damage that MagSafe charging tends to do. The version I got was absolutely not an Apple product and not smart, and had to go through some runaround with eBay to get them to refund me on that. But I finally did, and I ended up keeping the battery. So my plan is to at some point bring it on this stream, take it apart, and see how what sort of danger I was able to avoid.
Isn't capacitive charging like that quite energy inefficient?
It is, yes, definitely energy inefficient.
So like, you know, the amount of capacity you would get by charging your phone like that relative to the size of your external battery pack is not going to be the same.
You'll get a full charge out of it, basically, but they tend to stop the charging at 80% anyway, again, just because topping up a lithium-ion battery takes more intensive charging power. And therefore more heat, and if you've got, you know, something covering it on the back and generating heat from both sides, it's that heating of the battery that causes a lot of the damage as well.
I wish somebody could figure out or that like to make tablets. Like I wish my iPad could capacitively charge.
Yeah, were we supposed to get like targeted microwave charging by now?
Like
Hey, that is pretty. Yep. And I think we can absolutely this seems just a bit brighter to my eyes than they were individually via a partially charged battery pack. So I think they're actually getting the voltage that they kind of want.
I mean, they haven't run with the battery packs in a long time, so I don't really remember how bright they were. But
Well, I was remembering. I mean, we can very easily just test here by reconnecting one of the battery packs. I'm very happy that I've created a solution that does not change how these operate as well.
That's super cool. You're able to just plug into the existing. Oh yeah, those are quite a lot brighter.
Yeah, they're only putting out right now 20 amps. What are we getting out of this thing?
Like, I don't know. I get that tablets require a bunch more power, so it wouldn't be, but like, you know, I leave my tablet on my bedside all night. It could just sit there quietly,
Yeah.
slowly charging. I don't quite see why that isn't possible, but anyway.
So this battery pack is currently only putting out 2.62 volts.
Right. And we're running 9 through all 3.
Exactly. So let's see what the power draw is on this amperage wise. I'm curious.
Right, because that is only a 200 milliamp plug.
Yeah. So 200 milliamps, you say? Let's go to 20 milliamps. And boop and boop. Oh, am I the wrong way? Oop. Okay, wait a minute. Ground to ground.
Oops.
Yeah, no, it's
Why is it turning off? When,
because I'm shorting the circuit
Oh.
whenever I do that to test the amperage. But yeah, that just shorts it out. Well. Oh, right, because that's
you're trying to measure current in parallel, you should be doing it in series.
yeah.
Amperage in series. Yeah. I don't.
Am I using the wrong connector here? 10 amps. Yep. I think I'm using the wrong side.
So people were saying that the L looked like it was brighter than the others. I think that might be just the perspective on the camera.
I
Like
think so.
depending on what angle it's on, it looks different.
Okay. Well, regardless, I'm rather pleased at how that came out and that we can just put this on the set as is, quite frankly. I guess the only real addition that I could add to this would be some sort of a switch to turn it off easily, but
Yeah, that would be nice rather than having to unplug it.
yeah. That's, you know what let's consider that a project for future Moonbase mock-ups. But yeah, I'm really happy with how that came out.
Yeah, it's a stuff, and yeah, someone pointed out, as someone says in the chat, they're those are quite nice, sort of warm LEDs,
They definitely have a
and especially with they have little globes around each LED to try to make it look like that kind of theatrical lighting. That is quite nice.
I really honestly I enjoyed them when a couple of them are burned out too. You kind of or just unscrewed because it kind of adds to the.
I forget where we got that.
I'm pretty sure these were picked up from Winners, I think. But that definitely would have been a long time ago. Definitely pre-pandemic, but
Oh yeah,
Yeah.
I mean, like as I said, I think those are. I think we had those in Moonbase Mark IV, at
Pretty
least
sure.
in Delta. Yeah.
yeah. But yeah. Let's we're gonna get those up on the wall. You know what? Let's have them on for the remainder of the show. And by the remainder of the show, I think we're going to call it there, actually, because that seems like a good place for us to naturally finish up. So I want to thank everyone.
Retired champion.
Yeah. Thanks, everyone, for watching Tinker Tailor's Solar Fry here on the mighty Loading Ready Run Video Entertainment Network. Reminder that everything we do here is done by, well, it's done by us. But it's possible because of what you do over at patreon.com/loadingreadyrun. Thank you so much for keeping us funded there as well. Twitch.tv/loadingreadyrun and youtube.com/loadingreadyrun and store.loadingreadyrun.com. Great ways to support us all. And of course, we want to thank everyone involved with the program. Thank you, Paul, for helping us out here, and thank you to Heather for getting us up online. And of course, we will see. Oh my God, we're not going to see you, I think, till the new. We're going to see you sometime in the future. But you can always check us out at loadingreadyrun.com/live for a schedule of everything that we have here on the program. So once again, on behalf of myself and everyone here, thank you for watching, and we will see you usually in a fortnight, but never in fortnight. We're ever forward, moving forward, learning out of spite. Good night.